Hey everyone, welcome to this episode for the Physical Setting Chemistry New York Regents exam, looking at determining molecular and empirical formula. Right, so the empirical formula is the simplest formula for a compound. The molecular formula gives the number and types of atoms in a compound. So the empirical formula is the simplest whole number ratio of the atoms in a molecule. For example, ethane has 2 carbon atoms and 6 hydrogen atoms, but CH3 is the empirical formula for ethane. A molecular formula is the actual number of atoms of each element in a molecule. It is always a multiple of the empirical formula. Always. For example, ethane has 2 carbon atoms and 6 hydrogen atoms, right? So C2H6 is the molecular formula of ethane. It's twice the empirical formula, for all those eagle-eyed viewers out there. The empirical formula of a compound is often very easy to determine experimentally. For instance, you could combust a hydrocarbon and find that you get twice as much water vapour as carbon dioxide. This would tell you that its empirical formula is CH4, because remember, H2O has 2 hydrogen atoms. A molecular formula is relatively difficult to determine experimentally, is how it is. So, let's have a look at an example. Combustion of an alkane produces 3 moles of water and 2 moles of carbon dioxide. What is its empirical formula? So, step 1, calculate the number of moles of hydrogen atoms in the water. 3 moles of water contains 6 moles of hydrogen atoms. Then calculate the number of moles of carbon atoms in the carbon dioxide. 2 moles of carbon dioxide contains 2 moles of carbon atoms. Then calculate the ratio of carbon to hydrogen. The ratio of carbon to hydrogen is 2 to 6. Then simplify to the lowest whole number. So it simplifies to the ratio of 1 to 3. Write out the empirical formula, CH3. Nice. Okay, so what is the empirical formula for ethane? CH3. Okay, that's all for today. Good job, everyone. We'll see you on the next episode. Okay.